Following the discovery of Wanj Ein I Oumuamua in 2017, the sky is being watched. Now, a new object, 3I Atlas, has been detected. It is also interstellar, a messenger from the void between the stars. It is an extraordinary scientific opportunity. But in the public mind, an object from deep space triggers a more primal, immediate, and visceral question. Will it hit us? This fear is not unfounded. It is embedded in our planetary memory. We have seen the dashcam footage from Chelyabinsk. We know the story of Tunguska. We know, as a species, what happened to the dinosaurs. Our collective consciousness is primed to see an incoming object not as a curiosity, but as a threat. The arrival of Oumuamua set the stage for mystery, for speculation about alien probes. The arrival of 3I Atlas, which is visibly a comet, sets the stage for a different kind of speculation. The disaster movie scenario. Media headlines and algorithm-driven content are quick to seize this narrative. Interstellar object approaches. Comet to buzz Mars. The proximity of a word like Mars to a word like comet can, in itself, create a sense of unease. If it is close to Mars, is it close to us? This is a script about that question. It is a script about risk, perception, and the power of mathematics. The universe, at this scale, is not a place of random chance. It is a clockwork. It is governed by a force we have understood for centuries. Gravity. The planets in their orbits, the moons around those planets. They all follow precise, predictable paths. A new object, even one from another star, does not get to ignore these rules. From the moment 3I Atlas was detected, its trajectory became a mathematical certainty. Every new observation from Hubble, JWST, and ground-based telescopes has not been to guess its path, but to refine the precision of our knowledge of that path. This is the central tension, the difference between a frightening headline and a boring orbital plot. This is where media hygiene, the ability to distinguish data from drama, is critical. The story of 3I Atlas is not one of planetary hazard. It is a story of why it is not a hazard. The answer lies not in hope, but in physics. To understand why we are not alarmed, we need to understand the fundamental law of the solar system. It is not chaos, it is a machine. Hundreds of years ago, Isaac Newton and Johannes Kepler explained this machine. They gave us the laws of motion and universal gravitation. These laws are not suggestions. They are the non-negotiable physics that bind the cosmos. Every object, from a grain of sand to a galaxy, must obey them. The sun, which accounts for 99.8% of all mass in our solar system, is the undisputed master. It creates an immense gravitational well. You can picture this as a bowling ball, the sun placed on a vast flexible sheet. The planets are not flying randomly through space. They are marbles rolling in the deep, circular grooves created by the sun's mass. Their paths are stable, predictable, and have been for billions of years. An interstellar object, like 3I Atlas, is a new marble dropped onto this sheet from the outside. It arrives with its own speed and direction, but from the moment it enters our system, it is captured by the sun's gravity. Its path is no longer a mystery, its path is now a calculation. This is the science of orbital determination. It is one of the most powerful and precise tools we have. When 3I Atlas was first detected, it was a single point of light. That one observation told us where it was. A second observation, hours or days later, told us where it was going and how fast. With just 2 data points, we could draw a line, an initial best guess orbit. This is the process. We take those first observations and feed them into the clockwork. The laws of gravity are the engine. We run the calculation. The computer plots a path, a hyperbolic trajectory. This trajectory is a prediction. It says, if our laws are correct, in 24 hours, the object will be here. Then we wait. We point our telescopes to that predicted spot, and invariably, the object is there. This new third observation is added. The calculation is run again. The uncertainty box, the small area of where the object might be, shrinks. Every single night, this process repeats. Hubble, JWST, the Atlas array, every new observation is a nail that fixes the trajectory more firmly in place. The uncertainty shrinks from thousands of kilometers to hundreds, then to tens. This is why, for scientists, the "is it a threat" question is usually answered before it is even asked. The object is not wandering. It is not on a maybe path. It is on a fixed gravitational groove. The math is not ambiguous. It is absolute, and it has already told us the answer. So, what is the path, and how sure are we? This is not a guess. The world's observations, every data point from every telescope, are sent to central clearinghouses. The two most important are the Minor Planet Center, MPC, and NASA's Jet Propulsion Laboratory, JPL. They are the impartial referees. They run the numbers independently, and they agree. The gravitational path for 3I Atlas is now known with a precision that leaves no room for ambiguity. The object will reach perihelion, its closest point to the Sun, in late October 2025, inside the orbit of Mars. After this, the Sun's gravity will slingshot it back out, on a trajectory that will bring it near the geometry of Jupiter on March 16th, 2026. These are not separate events. They are all part of a single, continuous, calculated path. The tiny gravitational tug from Jupiter, which won't even happen for months, is already in the equation. It has been modeled, and that model tells us definitively what the risk is. The risk to Earth is zero. The trajectory of 3I Atlas is not just a miss, it is a miss on a cosmic scale. At its closest point, the comet will pass Earth at a distance of approximately 1.4 astronomical units. 1 AU is the distance from the Earth to the Sun, 150 million kilometers. So, its closest approach to us is 1.4 times that distance. But there is another, even more fundamental safety factor. The object is not even on our highway. Think of the solar system as a flat disk, the ecliptic plane. Earth, Mars, and most of the planets orbit on this flat plane. Hyperbole Atlas, however, is arriving on a path that is steeply inclined to this disk. It is coming from below the plane, and it will cross above it on its way out. It is a highway overpass. The comet's path and Earth's path will never, ever intersect. They are not in the same space. The gravitational path is a closed case. The object is not, and has never been, a threat. The math is simple, and it is final. This brings us to the source of the anxiety, the language. We read headlines that the comet would have a close encounter with Mars. And these headlines are technically true, but the tension is in the definition of the word close. Around October 3rd, 2025, 3I Atlas made its closest pass to the planet Mars. This event just happened. For weeks, the media framed this as a moment of high drama, a buzz of the red planet. But what does close mean in astronomy? The solar system is almost entirely empty space. The distances are beyond human comprehension. Earth and Mars, our neighbors, are, on average, over 200 million kilometers apart. They are two ships sailing in entirely different oceans at different times. The 3I Atlas flyby of Mars was not close in any human sense. At its nearest point, the comet passed Mars at a distance of roughly 14.5 million kilometers. That is 37 times farther away from Mars than our own moon is from Earth. If a rifle bullet passes 37 feet away from you, you did not have a close call. You were never in danger. The event was irrelevant to your safety. For astronomers, the Mars flyby was not a risk, it was a gift. Testable predictions. This was our first and only chance to get high-resolution data from our assets already in place. We couldn't send a probe to the comet, but the comet was coming relatively close to our probes. This was a critical scientific opportunity. As the comet passed, ESA's TGO and NASA's MAVEN sampled its coma. MRO's high-rise camera, the most powerful lens in deep space, was reoriented. It captured images of the nucleus, not to see if it was a threat, but to study its morphology. Perseverance rover may have even seen it from the surface. This data, gathered just before the comet entered its solar conjunction blackout around October the 21st, is now being analyzed. It confirmed a critical fact. The object arrived at Mars at the precise moment on the precise trajectory that the gravitational clockwork said it would. Close to Mars did not mean danger for Mars, and it meant even less for Earth, which was on the other side of the solar system at the time. The flyby was the ultimate confirmation of our safety, but there is a wild card, a what if. The gravitational path is a clockwork, yes, but what if the object itself has an engine? What if it can push itself off this path? This is the tiny, nagging question that must be addressed. Comets, by their very nature, have engines. They are not controlled engines, but they are engines nonetheless. As 3I Atlas passed its perihelion in late October 2025, the sun's heat was at its most intense. This vaporized the ices on its surface, causing jets of gas, mostly CO2 and water vapor, to erupt like geysers. These jets, like tiny thrusters, create a push. This is non-gravitational acceleration, or NGA. It is the single biggest X factor in orbital mechanics, and this is what made Oumuamua so infamous. Oumuamua had NGA. We observed it being pushed, but we could not see why. We detected no coma, no gas, no dust. It was a black box engine, all push, no visible propellant. This was a deep, unsettling paradox. Now, we look at 3I Atlas, which, as we speak, is emerging from its solar conjunction, and it is completely different. It is not subtle. It has a vast, visible coma. We see the chemical fingerprints of its exhaust. It is a classic dirty snowball. So we know 3I Atlas has NGA, we expect it. The real question is, could this push be strong enough to change its trajectory from a 1.4 AU miss into a hit? The answer is, unequivocally, no. Here is why. First, the force is random. The comet is a lumpy, tumbling object. The jets are not a single, coordinated thruster. They are chaotic plumes, firing in all directions as the nucleus spins. Over time, these random pushes largely cancel each other out. Second, the force is tiny. The sun's gravity is the 800-pound gorilla in the room, dictating the path. The NGA push is a gnat on that gorilla's back. It is a rounding error. In all our orbital calculations, this tiny, random NGA is already factored in. It is part of the noise, the uncertainty box. And even with this wildcard included, the path of 3I Atlas does not come remotely close to our planet. The wildcard is not a threat. It is simply another layer of fascinating and perfectly safe physics. This, then, is the real story of 3I Atlas. It was never a story about a hazard. It was a story about hyperbole. The trajectory of the object was the least mysterious thing about it. It was the first thing we knew, and we knew it with absolute certainty. The risk was never low. It was and is zero. Why then did the narrative of fear take hold? First, we are primed for it. The mystery of Oumuamua, which left us with unanswerable questions, created a vacuum. Any new interstellar object is now burdened with that legacy of strangeness. Second, fear is a more potent driver than curiosity. A headline that says, trajectory safe, risk zero, chemistry interesting is boring. A headline that says, dangerous interstellar object buzzes Mars is not. This is a failure not of science, but of media hygiene. We must learn to distinguish between the necessary cautious pace of scientific verification, institutional delay, and the paranoid fantasy of a coordinated silence. The facts were always available. The 1.4 AU miss distance from Earth. The 14.5 million kilometer miss distance from Mars. The steeply inclined orbit that meant it was never on our plane. These were not secrets. They were the first and most basic data points. The real story of 3I Atlas was far more subtle and far more interesting. It was in the spectroscopy. It was in the glowing green C2 swan bands. It was in the early unconfirmed reports of nickel without iron, a true chemical puzzle. It was in the MRO and TGO data from the Mars Flyby in October, which confirmed a CO2-dominated coma and a perfectly normal potato-shaped nucleus. Atlas was a spectacular success for science. It proved our models. It tested our observation networks. It gave us our first close-up chemical analysis of a new visitor. The only impact this object ever had was on our imagination. As it heads out past Jupiter, disappearing back into the interstellar night, it leaves us with no threat. It leaves us with data, and it leaves us with a critical lesson. In the age of information, the most important skill is learning to separate the signal from the noise.